commercial cells and batteries. So basically, and these are all electrochemical cell, as we know, and a cell and battery is basically uh, doing some chemical reaction and giving us electrical energy that you all know. And what are the basic criteria for a cell or a battery which can make it commercially usable? So can you tell me?
The rechargeable battery.
Yeah, but always that is one of the criteria. But not all batteries are rechargeable. So electrochemical cells, which we are using, batteries which we are using commercially, okay. The first thing is they must be compact. Suppose we studied in the first initial days of this electrochemistry topic, we were studying that we were doing the electrochemical cell with the zinc acting as anode and cathode, copper acting as cathode, okay, a Daniel cell which we have seen. And in that we have seen basically we need to put a U tube, that was the salt bridge, into two beaker and the solutions over there in the beaker, and a zinc rod was dipped in zinc sulfate and copper rod was dipped in copper sulfate solution, and they were connected with a wire and all. So that was a cell, that is good. But to carry it every time, it can be a bit tricky because there were two containers and you need to, there were liquids filled in those containers. So it was actually a bit difficult for us to carry that whole setup, right? So that we should not, the commercial cell or the battery should not have that kind of setup. It should be easy for us to carry, so it should be portable and compact. Got it? This is first thing, so that it can be carried away wherever it is required and it can be used with ease. Next is the drop in voltage uh, while in usage should not be drastic. Okay, the voltage of a cell or a battery which you are using, that should be maintained, okay, to some steady value. So the cell or battery must supply steady voltage. So the voltage should not drop abruptly. It should not drop suddenly during the use. So this I hope is clear to all of you. So these are the basic criteria which you should write. And there are three types of cell or batteries. So Aisha, Marwa, can you tell me what are the three types of this Jesslyn? What are the three types of batteries?
Primary batteries, secondary batteries,
Yeah, primary, secondary, and
fuel batteries.
yeah, fuel cell, right. So we have primary cell, secondary cell, and fuel cells. So what is the basic difference between the primary cells? What do we mean by primary cell?
They cannot be recharged,
Yeah,
reused.
yeah, exactly. So primary cells actually they cannot be recharged. That is the basic difference. Okay. And what about the chemical reaction which is happening? Because it cannot be recharged, what can we say about the chemical reaction?
It stops.
Yeah, it stops, and if you pass the reverse voltage, if you apply the reverse voltage, the reaction cannot be reverted. Okay. So the chemical reaction which these cells are using, primary cells, cannot be reversed by passing electricity. And this is the main reason why they are not reusing it. Okay. So because this chemical reaction cannot be reversed, so the chemical reaction stop, as you said very correctly, and the cell become dead after usage. Right. And what are the examples of primary cells? And the one more thing, these cells, the amount of reactant which we are having in these cell compartment, they are limited. And during the reaction, all of these reactant get consumed. And the moment reaction stop, the cell is dead. Okay. So limiting limited amount of reactants. And when the cell get discharged, all of these reactant are consumed, that indicate the cell is discharged. Okay. So we can start with the primary cell. What are the examples of primary cells? Jasleen, any idea what are the examples of primary cell? Or Aisha? We use them in our daily life. Okay. And they are
So
actually dry
the
cells. Yeah.
batteries used in watches, like the small
Yeah, the
batteries.
batteries which we use in watches, very true. The batteries which we use in clock, okay, that pencil cell in remote
Mm.
controls, okay. So all those are basically primary cells, okay, and they are known as dry cell. Nuclear cell. What is the voltage range of voltage they are providing? Any idea? What range of voltage the dry cells or Lickland cell are providing? They are around, if you try to look at the pencil cell, they will give you 1.5 volts of voltage. And how the reaction happens, and then what reaction is there which can which takes place when they are giving electric current. So what reaction they are having? Any idea? So we need to have the anode and cathode. We need to have two set of reactions, anode and cathode, right? So anode is actually basically the the zinc compartment. The cell is made up of zinc compartment, right? And that is basically the anode. Zinc, just like in the Daniel cell also, where we had seen galvanic cell in the beginning of this chapter, the zinc is very electropositive, it loses electrons. And this reaction is taking place in a zinc container. The whole cell, if you remove the outer label of that cell, you will come to know that basically that is uh, it is made up of zinc. Normally, that covering there is a covering because of which we are not able to see that zinc. But if you remove the covering of that cell, you will be able to see a grayish, silverish container of the cell. That gray container or the grayish silvery container is basically the zinc container. Okay, and that is acting as an anode. So it is going to be negatively charged because zinc has a tendency to lose electron and it will be filled with the electrons. That is a negative charge. And in the middle portion, there is a graphite rod. Okay, there is a carbon rod in the middle portion that acts as a cathode. that is acting as a cathode, the middle compartment of the cell. So you might have seen that there is a positive sign written on that middle portion. You might have observed. Okay, the positive sign, the cathode is positive. So we can draw the rough diagram. And this is the zinc container, and in the middle you have a carbon drive. This electrode acts as a positive, and this acts as a negative. So zinc reaction you already know. What is the reaction which is happening at the cathode? Can anyone of you tell me? Jasleen, Aisha, Maria, what is the reaction which is happening at the cathode? Anode reaction is very simple. I have written the anode reaction. This is a carbon or a graphite rod. So it is basically surrounded by the dry paste of that MnO2, black colored paste of MnO2. MnO2, and that is mixed with ammonium chloride. Okay. So MnO2 basically undergoes the reduction. What is the oxidation state of Mn? It is basically +4, and it changes to +3 as it accepts the electron which is lost by the zinc. So I will write the equation. You have the MnO2 NH4Cl. It accepts electron. It changes to MnOOH. NH3. And Cl minus is free. So this electron, which is given by zinc, is taken, is accepted by the manganese, MnO2. What is the change in oxidation state? It is manganese is +4 and it changes to +3. Got it? Is it clear to everyone? Aisha, Marwa,
Yes, sir.
any doubts in this? So this is MnO2 surrounding the cathode, and it is because it is MnO2 dry powder. So you mix it with NH4Cl, moist NH4Cl. Okay. The anode, the zinc, actually I have written the skeletal equation. So actually what is happening is the zinc which is being formed, that zinc accepts the, that zinc reacts with the ammonia NH3 and forms ZnNH3. This forms a complex zinc plus 2. Is it clear? So that's how the reaction happens. and it provides us with a voltage of 1.5 volts, right? And mostly as the zinc, sometimes what happens, sometimes we may see that the cell may leak poor quality cell. So why the cell may leak? What is the reason that the cell may leak? It may leak because the zinc is getting consumed. And because the zinc is getting consumed, it may develop holes if the container is not of proper quality. It may develop holes in the walls of the container. And because of this holes, the cell content may start leaking. That happen with the poor quality cell because zinc is getting consumed and may cause, if the container is very thin, then it can happen, and it may cause the, what is the other type of cell which we are using, which we use? As you said correctly, what was the other type of primary cell? Who will give me the example? Jasleen, Aisha, Marwa. What is the other type of cell? The other type of cell is the mercury cell, which we use in hearing aid, watches. So basically, these cells are used when you require a cell which gives you require them at a place where the less current is required. Okay? So that is the mercury cell. So the less current is required, then you can use the mercury cells. Okay. So low current device, you can use them, and you have a uh, zinc amalgam. Basically, you have zinc as anode. Zinc is very important because you know that it is highly electropositive. So zinc amalgam is used as an anode. Got it?
Yes, sir.
And the zinc is losing electron, but you have taken some basic medium in it. Okay. Zinc amalgam alloy of mercury is known as amalgam, and many metals can get dissolved in mercury. So the zinc loses electron, it forms zinc plus 2, and it becomes zinc oxide, water. Do you have two hydroxide ions? So out of two hydroxide ions, make one as water and another as oxide. Oxide is going to club with the zinc 2 plus, and the 2 electrons are being released. Got it? And you have cathode. Cathode is mercury cathode, HgO. That accepts 2 electrons and change to mercury. So these cells are normally very small, okay? And the button cells which we are having in our electronic watches, okay, they are like this, very small in size, just like the button. So you have some anode, you have some zinc, amalgam, and in the middle you have a separator if you try to break them, okay, and the bottom you have cathode. So here you have HgO being placed, and in the top compartment you have zinc, amalgam being placed, okay, mostly used in electrical watches where the current requirement is very low. It's provide a voltage of 1.35 volts, right? The drawback is the usage of mercury. That is an environmental hazard because mercury is not good for health and it will slowly get into the water. In the middle, you have a porous partition, okay, and that separates the zinc compartment at the top and the cathode compartment and HgO compartment at the bottom. Is it clear? So this is how basically you are having this. Hence, the button cell which you have in this your watches work. Now let's move on to very important cell, that is second category of cells and batteries, and those are secondary cells. What are secondary cells and batteries? What do you mean by Aisha? Or what, tell me? What do you understand by secondary cells and batteries? Any
So
idea?
they're rechargeable,
Yeah, they are rechargeable. Exactly. And how they are recharged?
like the phones and laptops.
By?
Like phones.
Yeah, exactly. Like in the mobile phones we are having. And the recharging, it is because their reaction is reversible. Okay, the nature of the chemical reaction is such that it can be reverted. Okay, so they rechargeable means they can be recharged by passing electric current, right? And when you apply the voltage, so normally if you don't apply the voltage, their reaction is automatically, it will happen and it will generate the current. Once all the reactants are depleted, then you can connect them to external electric supply. They will consume the electric current, and that during the consumption of electric current, so whatever the cell reaction has happened, that will revert back. Okay, and again you have the cell ready for the next cycle of usage. So basically, the most famous example of this, and which is discussed everywhere, most important, playing a most important role in our life, is the lead storage cell, and where it is used. Where we use the lead storage cell. These are there in the car batteries. We use it in the car battery. Okay, basically this is they are made up of lead compartment. Okay, there are a lot of lead compartment are clubbed together. Okay, so each individual, and that each compartment, each individual cell is having a voltage of 2 volt. And normally you have 6 units are combined together. Are present in car batteries. So the car battery is the voltage is 12 volt. Got it? Overall, because each compartment is having, each cell is having 2 volt, and you have normally 3 to 6 unit depending upon the usage. Normally in our cars we are having the 12-volt batteries, right? So what about the anode and cathode? Both are made up of lead only. Okay. So can you tell me what about the anode and cathode? Who is going to tell you? Anode consists of the lead plates, and they are placed parallel to each other. If you open the battery compartment, you can see the lead plates are there. Okay, and basically these are uh, filled with spongy lead plates, and they are filled with spongy lead. Then after this, you have equal number of plates placed side by side to them. Okay, there are equal number of plates placed by their besides these plates, and they will make the cathode. So cathode consists of PV. What are the reactions? The reaction is very simple, and the electrolyte which in the cell, which is filled with the H2SO4. So what you do is basically the reaction at anode is Lead is there that reacts with the sulfate, okay, and it forms Pb. The lead loses two electrons. It changes to PbSO4 solid and releases two electrons. On the cathode side, you have PbO2, okay, lead dioxide. So this is also H2SO4. It is present in sulfate. H2. The sulfate is because of the H2SO4, which is filled in the hole of the lead battery compartment. Lead. This is lead plus 4. It accepts two electrons, which were given by the lead at anode, and it changes to Pb2 plus. It also forms PbSO4. Is it clear? The overall cell reaction, if you write, if you add anode and cathode compartment, so lead is there at anode, PbO2 is there at the cathode, H2SO4 you want two H2SO4, okay, and because both the lead will change to this is 0 and that is plus 4. 0 will become plus 2, plus 4 will also become plus 2, and both will become PbSO4, okay. So both are going to become PbSO4, right? And this this oxygen and this that is going to change to water, H2, twice H2. Is it clear? This is the overall cell reaction, and these cells are, each cell is of generating the 2 volts of voltage, and they are placed side by side. So overall, they are placed alternate, right, side by side, so that the overall voltage which is generated will be of 12 volt in a car battery. Is it clear? So this whole of the arrangement, so you have this lead, you can, you have these lead plates being suspended, okay, and then you have PbO2 plates alternately placed, okay, and the whole setup, these PbO2 and Pb plates, they are actually they are basically separated. Uh, Outside they are connected, but each compartment is separated by thin fiber sheets or plastic sheets. Okay, that you don't need to know. The most important thing is this whole thing is basically these whole plates are dipped in H2SO4 solution, dilute H2SO4. And this dilute H2SO4 is 38% by mass, and it has a density of 1.31 gram per ml. This you need to know. And this is also used to check the health of the car batteries. Normally you might have noticed on that I don't know if the car battery is not functioning properly. So when we get it checked, they check the density of the H2SO4 present in the car batteries. And if it is not of the proper density, if the H2SO4 is less, means the cell is not properly functioning. Is it clear? That was the reaction for discharging. The lead is giving electron, PbO2 is accepting electron, and that's how the current is flowing. So H2SO4, which is filled, it need to be checked again and again because it is used up during discharging. And if the density falls below 1.2 gram per cubic centimeter, it will stop working. So this thing you need to know. Okay. And if because H2SO4 basically, and we need to put distilled water. Okay. Because that is water is also get electrolyzed slightly, very slightly, and it may get evaporated also slightly. So we need to replenish the cell with H2SO4. Got it? To keep it working properly. Okay. And how the recharging, because it is a secondary cell, it need to be recharged again. So how the recharging occurs? So the recharging is taking place by it. It becomes initially during the discharging, it was electrochemical cell, and during the recharging, it becomes electrolytic cell. So how the recharging takes place? How the recharging is taking place basically? So everywhere you have PbSO4. Am I audible to all of you?
Yes, sir.
So everywhere you had PbSO4. That PbSO4 accumulated either from the lead or PbO2. Okay. So basically, you have PbSO4, and when you pass electric current, okay. So this PbSO4 at the anode compartment need to get it. We need to get it converted back to Pb. So you supply electric current, and if the lead accepts electric current and change to Pb, and two sulfate ions get separated. So whatever the reaction which you have seen, that is being reversed. You write the same reaction in a reversible manner. Same is the case. This is the anode, right? That was happening. And reaction at cathode, you are having PbSO4 at cathode, because that also converted to PbSO4. You can see here, cathode also got converted to PbSO4. Okay. So PbSO4 and H2 changes to Pb and PbO2. So this is how PbO2 and Pb is being formed again. Okay. So recharging the PbSO4 formed during the discharging. So there can be a question. So what is being formed in the discharging process? Just remember it. PbSO4 is being formed in the discharging process. Okay. And that PbSO4 stick onto the electrodes because it is solid. And how it is converted back to lead or PbO2, that is by supplying voltage during the recharging, by supplying electric current by in the recharging process, that PbSO4 get converted back to Pb, either Pb or PbO2. So I hope this is clear to all of you, right? Next is, can you give me example of another secondary cell? Lead acid cell, lead acid batteries, the car which we use in car, which the anode is made up of lead, the cathode is made up of PbO2. They both turn to PbSO4. H2SO4 is the electrolyte. Okay, that's what we had seen. Rechargeable cells and batteries. Any other example if you remember of rechargeable cell and batteries? Any other example? Jaslyn, any idea? Aisha, Marwa?
So nickel,
Yeah, nickel
mm,
cadmium.
cadmium.
Yeah, nickel cadmium cell. That is the another example of rechargeable cell in the batteries, right? So that is also being used uh, at places, some of the places like in cameras we are having now, but most of the cases we are having most of the cases we are having lithium ion batteries. Okay. But other electrical equipments, the normal electrical equipments where you have recharging, where you seeing the recharging taking place, that you have nickel cadmium batteries. So what are these nickel cadmium batteries? Just you will write the reaction. Okay. No need to get into the detail. Okay. First you have nickel and cadmium being available. Okay. That is the nickel cadmium battery. So cadmium is electropositive. We know that it is a metal. It will lose electron. And you have nickel in the form of nickel hydroxide. Okay, this nickel hydroxide. Cadmium, zinc, cadmium, and mercury both can lose two electrons. So cadmium loses two electrons and changes to cadmium 2 plus, that combines with oxygen from CDO, and the nickel accepts one electron. So this one is given two electrons. So two nickel, this is nickel plus 3, and it will show 2 plus 2. Right? Got it. So it's cadmium is the anode and nickel is the cathode while discharging. So this I hope is clear to all of you. You need to remember. And the last, which is the most important from the present day scenario, that is fuel cell. So what do we mean by fuel cell? What are the advantages and disadvantages of fuel cell? Any idea? Basically, it is just like there is no storage of reactants. Okay, it's not charging and discharging. It is just like burning of fuel, but instead of burning, we are doing redox reactions. Instead of direct burning, which where we see the flame, that burning is also basically the redox reaction. But most of the energy goes in heating in the form of heat and light. But if we do some controlled redox reaction, where we don't burn the fuels, we let them pass through the catalyst, okay, and let them exchange electrons without real burning, okay, without real flame. The idea is same, but you don't burn them directly. Indirectly, you are doing the same reaction, redox reaction, which happens during the combustion process. But in combustion process, what is happening? We are having the heat being generated, and heat is basically used to boil water in turbines or in thermal power plants, and that boiling water changes to steam, and steam is used to drive the turbine. Okay, that generate electricity. So there is a lot of efficiency, yield loss, okay, energy loss during this transformation from one form to another. So why not convert the direct reactions, okay, to directly do them in a way that they can generate electricity directly. So we should not rely on generation of steam. We should not rely on any turbine or power plant. We can directly burn those fuel. We can directly let them participate in the redox reaction at anode and cathode, and they can directly generate electricity with the help of suitable catalyst. That is very important. Okay, so you don't need to store the reactant. That is the main advantage. Okay, and you need to continuously supply the fuels, and the cell is as long it is going to work as long as the fuels are being supplied. And what is the byproduct? The byproduct is water. Okay, byproducts of this fuel cell is water. So environmentally also it is very friendly. Okay, but the problem is the catalyst. The catalyst need to be very selective, and it need to be very it need to be used for over a long period of time. Okay, so that is very very important. Okay, it was used in Apollo program during the moon landing. Fuel cells. Clear? So let me explain the details of this process. That if the screen is so let me share it again. So hydrogen and oxygen normally we burn them directly when the water is being formed. So instead of burning them directly, what we do indirectly we can let them participate in the redox reactions. So basically, this is the fuel cell, and these are the porous catalysts. H2O being formed. Anode and cathode. On the anode side, you supply hydrogen. On the cathode side, the reduction is happening, so reduction can happen for oxygen. Okay. Okay, what is, and the byproduct is water. You have electrolyte, and these are the porous catalyst around the side through which when hydrogen and oxygen are passed, the redox reaction happens. Okay. So at cathode, oxygen accept the electrons. Reduction of oxygen. Oxygen cannot be oxidized because it is already oxygen. It can get reduced. It accepts the electron. One oxygen atom can accept 2 electrons. O2 can accept 4 electrons. And you have this reaction, hydroxide ion, 4OH minus has formed. At anode, reduction will, oxidation will take place. Hydrogen can get oxidized. So hydrogen will lose its electrons, and if the hydrogen loses electrons, it forms H plus. That all of us know. That was happening in the standard hydrogen electrode also. So hydrogen loses electron, it forms H plus. And I need 4 electrons because there you had 4 electrons. You can see here. So 4 hydrogen atom and 2 H2 I need to take. 4 hydroxide I need to take. So they will become 4H plus by losing 4 electrons. 4H plus and 4OH minus will form 4 what? And 4 electrons are being released. Got it? That's how the reaction happens. So what is the byproduct? The byproduct is, if you add the two equations, okay, the byproduct is water. OH minus will get cancelled, electrons will get cancelled, okay, and you have water as a final product of electrolysis. Uh, Water as a product of not electrolysis, this electrochemical cell, and it is 70% efficient. This efficiency is more than the normal thermal power plant, which runs at an efficiency of 30 to 40%. So if you directly convert uh, them to electricity, that is more appropriate. Okay. So they are the catalyst is the porous carbon. Okay, and you have the OH minus porous carbon section is there on both the sides, which you can see. And on these porous carbon sections, you have the platinum or palladium coated on both the electrodes. So these electrodes, they are made up of porous carbon, okay, coated with Pt and Pt. Okay, and when the porous carbon to increase the surface area, okay, so that helps the oxygen to accept electron and hydrogen to lose electron. I hope this is clear to everyone. Now, the last part is corrosion. Corrosion in rusting. So in corrosion and rusting, you know that the many metals get corroded, they get oxidized in the presence of air and water, and it is basically a redox reaction. In the case of iron, it is well known to us as rusting. When you have iron being oxidized to Fe2 plus, and it loses the 2 electrons. Okay. Oxygen on the air, and you have H plus. Oxygen accepts the electron, 4 electrons, and it changes to water. Right? And in the so normally this is Fe2 plus. This at Fe2 plus in the air, atmospheric air, this Fe2 plus in the presence of atmospheric air, these get oxidized to Fe3 plus and forms Fe2O3. And this we know what are the harmful effects of the rusting. It causes a lot of economic loss. We know that, right? And a lot of rusting, it weakens the structure, iron structure, and it is initiated by the presence of water in air, and most water, impure water mostly, the saline water initiates the rusting because that's help in the transfer of electron easily, right? That's how it happens, right? So what are the protections from rustings? You have primary protection and secondary protection. Got it? So primary protection and secondary protection, and you use the paint. Okay. Uh, when you use to paint a surface, that is basically the physical protection, not the chemical protection, because that paint is going to stop the direct contact of iron with the air or water. So if the iron is not in contact with air and water, the rusting will not happen. Okay. There are other methods also, like you put a block of magnesium. Magnesium is more electropositive. In ships, we use magnesium, and block is kept. Okay. And that is connected to a wire. Through wire, it is connected to a body of the ship, because ships are always in the saline water, in the sea water, which is always saline. So basically, there are chances of the ship body getting rusted very easily. But magnesium being more electropositive, magnesium has more higher tendency to lose electrons. So magnesium will lose electrons before iron. Magnesium need not to be in direct contact with the salt water or the saline water. The block of magnesium can be anywhere. Okay. You can keep a small block of magnesium and connect it to the iron part. Okay. Whenever this iron part is coming in contact with water and air, the iron will get oxidized. Normally it happens. So basically the magnesium being more electropositive, magnesium will lose the electron and will not let the iron to get oxidized. Okay, this is sacrificial protection. You are sacrificing the magnesium to protect iron. Okay, but a small amount of magnesium can be kept being connected to the body of the ship, with the help of a wire. Normally, you also do galvanization, by dipping iron pipes in molten zinc, and that forms a layer of zinc on the surface of iron. And this is also sacrificial protection because zinc is more electronegative, more electropositive. It will lose its electron and it will not let the iron to get rusted. So you are sacrificing the zinc to protect the iron. Is it clear? You can also do the coating of tin, but that is not very fruitful as far as the protection against rusting is there. Just that molten tin can also be used, just like the galvanization, right? So let me start with a new chapter now, right? And this with this we complete the chapter of electrochemistry. And let me start with the chapter of chemical kinetics or alcohol ethers. Yeah, which
The
one should
chemical
we start?
kinetics.
Chemical kinetics we can do. Okay, so let me start with chemical kinetics. Okay, that also is a very interesting chapter, chemical kinetics. So first of all, how will you define chemical kinetics? What it is about? So it can be asked in 1 mark question, right? So it is basically the branch of chemistry which deals with the study of rate of chemical reaction. It deals with the study of rates or speeds of chemical reaction. These reactions, chemical reactions, can be very fast. They can be very slow. They can be in class 11th. You might have studied chemical equilibrium and chemical thermodynamics. Equilibrium and thermodynamics both are not related to the speed of the chemical reaction. Okay. They just tell you chemical equilibrium was about the reversible reactions. It will not tell you in how much time the reaction is going to get completed. On the other hand, thermodynamics was bothered about the feasibility of a chemical reaction. Thermodynamics helped us to know that whether the reaction is going to happen or not. Okay. So these were the two chapters which you have studied, but both were not related to the rate. Okay, so that's why we have a separate chapter of chemical kinetics, which is basically helping us to study the speed of the chemical reactions. Okay, so the reactions can be very fast reactions or instantaneous reactions. They can be very slow reactions like rusting, we just now discussed. Very slow reactions, and you have reactions with moderate speed. reactions proceeding with moderate speeds or rates. Okay, this is basically instantaneous reaction. We have acid-base reaction, we have precipitation reactions, okay, and they happen in just 10 to the power minus 6, 10 to the power minus 12 seconds. For example, if you take NaCl and AgNH, what is going to happen? They are already dissociated into ions. You are having NaNO3 and the precipitate, white precipitate of AgCl being formed instantaneously. The moment you mix these two solutions, you have the formation of white PPT. Okay. The very slow reactions are rusting, right? Which is very slow, which take maybe days or weeks, or it may take months or years also, depending upon the condition, atmospheric condition. Formation of petroleum in the earth crust, formation of diamond in the earth crust, that formation of minerals in the earth crust, that may have taken long time. So these two reactions will not be studied in chemical kinetics. So what's the reason why they are not studied in chemical kinetics? The reason is because there is no point of studying very fast reactions or very slow reactions. So these reactions are going to be the part of chemical kinetics. Okay. So chemical kinetics is about the study or rate study of rates or speed of chemical reactions, and not only this but and the factors which affect them, and these factors can be. Can you give me example? Aisha, Marwa, Taslim, factors which affect the rate of chemical reactions. Temperature, catalyst, concentration. These are the three main factors which can affect the rate of chemical reaction. Got it? There are other factors also like presence of radiation, surface area, the nature of reactant. That also is there. But these are the three main: temperature, concentration, and the catalyst. Three main factors which can tell us about the um, rates of chemical reactions, which will affect their rates. Okay. Now, next thing is we are going to study the reactions which progress, which proceed with moderate rate, which are neither too fast nor too slow, and in this chapter. But the question is how to measure, how to check the speed. What parameter should we check to check the speed of a chemical reaction? So any idea, Aisha, Jasmine, or what? Tell me how do you check the speed of a chemical reaction? What you look for? Tell me quickly.
So the concentration.
Yeah, you check the concentration, how the concentration is changing with respect to time. Got it? Note down the change in concentration, and that's help us to check what is the speed, by what speed the reaction is proceeding. So speed or rate is measured by measuring the rate of change of concentration. The speed rate of change of concentration of reactant and product per unit time. So you try to measure the change in concentration. So you take two time interval, two time, and let's say 5 minutes and 10 minutes. So that the whole duration in between that two time interval is of 5 minutes, 10 minus 5. And during that time interval, what is the change in concentration? Okay. So it is the change in concentration. This is concentration which is mentioned in square bracket per unit time. And the unit is mole per liter per unit time. The concentration is mole per liter. Okay. And divided by time. So per second. Okay. Or per minute. Or you can mole per liter can also be written as molarity per unit time, or you can write it like this: mole per liter per minute, right? These are the units of rate of chemical reaction. Got it?
Yes, sir.
Here, any doubt in this? Aisha, Jaslin, Marwa. So, but with respect to reactant also you can check, with respect to product also you can check. Okay. This rate of change of concentration. Okay. For reactants, it is known as the rate of disappearance. Okay, if you call it in more detail, because the reactant are getting consumed, and if you try to change the if you try to check the final concentration and initial concentration, the final concentration is decreasing. So you put a negative sign so that you get a positive value. Let me write a equation. A giving you B. Okay. So for reactant A, uh, rate of consumption of A. Rate of consumption of A is basically the final minus initial. You take the difference, and because it is a reactant, its concentration is decreasing. So final concentration is less and initial concentration was more. So this term will be negative, but we know that rate should be positive. So we put a negative, okay? We put a negative sign. Negative sign is just you can keep in mind that the overall rate should be positive. It should never be negative. Okay. So for reactant, you put a negative sign, just it is just symbolic to make the value positive. Always remember that rate should be positive, and this is the change in concentration of air, delta concentration of air, change in the time, right? And because A was reactant, this delta A by delta T was coming out to be negative. To make it positive, I put a negative sign. Okay. So this is basically the rate of change of concentration of A with respect to time. The magnitude of it by minus sign, I have made it positive. This is also known as the rate of disappearance of A or rate of consumption of reactant A. Similarly, and this can be written this because I have taken two time interval. This is basically average. This represents average rate of consumption of A. Average rate of consumption of A. Rate of disappearance of A. Average rate is measured over two time intervals, between two time intervals. Okay. And what is the instantaneous rate of consumption? How will you represent it? Instantaneous rate of consumption of A is measured at a particular time interval. It is measured at a particular time interval. Okay. and that, or you can assume that the two time interval between which you are measuring the rate is, they are very very close to each other. It is just like the our train journey. We measure the average speed, okay, but instantaneous speed can be zero when the train is stopping at some station. It can be 110 kilometer per hour, so it can have different values. Average rate can have different values. Instantaneous, the average rate is actually the for the whole time interval. An instantaneous rate is that particular time about which we are talking at. The suppose if the train is at station, okay, it will stop. So the instantaneous speed is zero. Similarly, the instantaneous rate of a chemical reaction is the measure of the rate of a chemical reaction at the particular moment of time, and it is represented by dA by dt. Okay, because when the time interval is very very short, as you may be knowing in your maths, that it is called the differential of the concentration of A, and because it is A is reactant, so you need to put. So this is the instantaneous rate of consumption of A measured at a particular time interval, okay, particular time, and that interval is very very short. Means at one moment of time only you are measuring. In between two time interval, that two time interval will form one at a particular time if the difference is very short. Is it clear, Aisha, Jasleen, Marwa? So this is how it is represented. If it is asked that what is the difference between the average rate and instantaneous rate, average rate is basically measured over